Hello, welcome to another lesson. In this lesson, we are learning vulnerability scanning concepts. We are going to understand what vulnerability scanning is, compare OpenVAS and Nessus, explore different scan types, learn severity ratings with CVSS, and discover how to interpret result scans. Vulnerability scanning is essential for identifying security weaknesses before attackers find them. So let's dive in. What is vulnerability scanning? It is the automated process of identifying security weaknesses in systems, networks, and applications. It is a proactive approach to finding vulnerabilities before attackers do, and it is an essential component of any cybersecurity defense strategy. What do vulnerability scanners do? They probe systems for known vulnerabilities by checking against massive databases. They check for configurations and weak settings that create security gaps. They identify missing security patches that vendors have released. They test for default credentials that administrators forgot to change. And they detect insecure services and protocols that shouldn't be running. Now, why does vulnerability scanning matter so much? Because modern day organizations have hundreds or thousands of devices to secure. Manual security audits simply don't scale to that level, and new vulnerabilities are discovered daily with dozens of CVEs published every single day. Also, compliance requirements like PCI DSS, HIPAA, and SOC 2 mandate regular vulnerability assessments. And most importantly, scanning reduces your attack surface systematically by finding and fixing weaknesses before they are exploited. Without vulnerability scanning, you are flying blind. And with it, you know exactly where your security gaps are. Now, let's understand the difference between vulnerability scanning and penetration testing. People often confuse vulnerability scanning with penetration testing. They are related, but they are fundamentally different approaches. Let's start with vulnerability scanning. Vulnerability scanning is automated and tool-based. It identifies potential vulnerabilities by checking for known issues. It is non-invasive, meaning it doesn't actually exploit the vulnerabilities it finds. It is performed regularly, typically weekly or monthly, as part of continuous monitoring. It has lower cost and highly scalable. You can scan thousands of systems easily, and it generates vulnerability reports that list all findings. Now to penetration testing. Penetration testing, on the other hand, is manual and expert-led. It actually exploits vulnerabilities to prove they are real and demonstrate impact. It is invasive because it simulates real attacks against your systems. It is performed periodically, usually quarterly or annually, because it is resource intensive. It has higher costs and requires specialized skills, but it demonstrates actual risk and business impact, not just theoretical vulnerabilities. You might be asking that when should you use each approach? Use vulnerability scanning for continuous monitoring, meeting compliance requirements, and systematically identifying issues across your entire infrastructure. And use penetration testing for validating that your security controls actually work. Use it to test defenses under realistic attack conditions. And you can use it to get comprehensive assessment of your security posture. Think of vulnerability scanning as your daily health checkup and penetration testing as your annual comprehensive physical exam. In vulnerability scanning world, two tools dominate, which are OpenVAS and Nessus. So let's compare them. OpenVAS is free and open resource. It contains over 50,000 vulnerability tests covering a massive range of security issues. There are no licensing restrictions, so you can scan unlimited systems. It has community-driven development, meaning security researchers worldwide contribute to it. OpenVAS is best for learning vulnerability scannings. It is good for organizations needing unlimited scanning without budget constraints and for anyone who values open source transparency. Now to Nessus. Nessus is owned by Tenable and it is the commercial industry standard scanner. It has over 150,000 vulnerability checks, which is 30 times more than that of OpenVAS. Nessus Essentials is free but limited to 16 IP addresses. Nessus Professional is paid, starting from $3,500 per year, but it offers unlimited scanning. Nessus is best for professional security assessments, enterprise organizations, and situations requiring the most comprehensive vulnerability coverage possible. Now let's consider the types of vulnerability scans. Not all vulnerability scans are created equal. Different scan types serve different purposes. The first one we'll consider is the external network scan, or we call it network external scans. This type of scan attack from outside your network. It simulates an attacker's perspective from the internet. It also identifies internet-facing vulnerabilities that external attackers could exploit, and it tests your perimeter security, which is your first line of defense. Now to the second one, which is the internal network scan, or we call it network internal scans. And this one runs from the inside of your network. It simulates an insider threat or an attacker who has already breached your perimeter. It identifies internal vulnerabilities that aren't visible from the outside, and it tests lateral movement risks to know how far an attacker could go once inside. Now to the third one, which is authenticated scans. Authentication scan uses login credentials to dive deep into systems. It checks for missing patches inside operating systems and applications. It provides higher accuracy with fewer false positives because the scanner can see exactly what is installed, and it identifies software level vulnerabilities that aren't visible without authentication. Now to the fourth one, which is unauthenticated scan. Unauthenticated scan uses no login credentials, and it scans from an outsider's view. It provides surface level analysis only, checking what is externally visible. It identifies externally visible issues like open port and service versions. It is faster but less comprehensive than authenticated scans. Now to the last one, which is the web application scan. Web application scan is specialized for web applications and APIs. It tests specifically for OWASP top 10 vulnerabilities, which are the most critical web security risks. It detects SQL injection, cross-site scripting or XSS, and CSRF or cross-site request forgery. Different scan types find different vulnerabilities, and comprehensive security requires using multiple scan types. Now let's proceed to learn about vulnerability severity ratings. Vulnerability scanners use CVSS, which means Common Vulnerability Scoring System, and they use it to rate severity on a scale of 0 to 10. Critical vulnerabilities score 9.0 to 10.0 and are marked red. These are remote code execution vulnerabilities that let attackers run commands on your systems. They require no authentication and anyone can exploit them. Many are actively exploited in the wild right now. Action required is patching immediately, even within hours. A famous example of this is Eternal Blue, which has CV 2017-0144, which powered the WannaCry ransomware. The second one is the high, and high severity vulnerabilities score 7.0 to 8.9, and it is marked orange. These represent significant security risk with real potential for data theft or system compromise. They may require authentication but are still dangerous. Action required include patching within days. An example of this is unpatched Apache Struts vulnerabilities that led to the Equifax breach. The next one is the medium, and medium severity scores between 4.0 to 6.9, and it is marked yellow. And these are moderate security risks that are harder to exploit or have limited impact. Information disclosure issues often fall here. Action required include patching within weeks during your regular maintenance cycle. Example of this is SSL and TLS misconfigurations that weaken encryption. The next one is the low, and low severity scores between 0.1 to 3.9, and it is marked blue. These are minor security concerns because it is difficult to exploit with minimal impact. Action required includes patching during scheduled maintenance windows and maybe with no urgency. Example of this includes software version disclosure in HTTP headers. Now to the last one, which is the informational. And informational findings scores 0.0 and it is marked green. These aren't actually vulnerabilities, they are just information about your systems. And no immediate action is required for this, but they are useful for documentation. CVSS gives you a standardized way to prioritize what to fix first. Now let's consider what scanners report. Understanding scan results is crucial, so let me try to break down what vulnerability scanners actually tell you. For this, every finding includes the CVE ID, which is a unique identifier from the common vulnerabilities and exposures database, a clear vulnerability name and description explaining what is wrong, the affected software or service versions so that you can know exactly what is vulnerable, and the discovery date and timeline showing when the vulnerability was found and disclosed. All these are vulnerability details. The second one is the risk assessment. The risk assessment section includes the CVSS score, which is the 0 to 10 numerical rating we discussed earlier. The severity ratings include critical, high, medium, low, or informational. Risk assessment also includes exploitability metrics showing how easy it is to exploit the vulnerabilities found, and it also shows the impact analysis on confidentiality, integrity, and availability, which is the CIA triad of security. The next one is technical information, and technical information tells you the ports and protocols affected. It shows the vulnerable service or application running on that port, a description of the attack vector, how an attacker would exploit this, and the proof of vulnerability, which is the evidence that the scanner collected and is revealing the real issue. The next one is remediation guidance. Remediation guidance is incredibly valuable. It includes the recommended fix or security patch with exact version numbers, vendor security advisories and links to official information, workarounds if patches aren't available yet, and required configuration changes to mitigate the issue. Finally, we have references. References provide links to CVE database entries, vendor security bulletins with official statements, security research papers explaining the vulnerability in depth, and public exploit databases showing if exploit code exists. This comprehensive information helps you understand, prioritize, and fix vulnerabilities efficiently. Raw scans can be overwhelming. You might see hundreds or thousands of findings, and here is how to make sense of them. And to make sense of anything, follow the prioritization strategy. And what is that? First, sort by severity, such as critical and high vulnerabilities. You know that those ones will demand immediate attention. Second, assess exploitability. Ask yourself, is exploit code available publicly on sites like ExploitDB? And is the vulnerability being actively exploited in the wild according to threat intelligence? And thirdly, evaluate business impact. Ask yourself, what are the systems affected? What data could be compromised? What is the business criticality of those systems? And to the fourth one, consider exposure level. Ask yourself, are these internet-facing systems or internal systems? How many hosts are affected? And what access controls already exist to fix this? And to the fifth one, verify findings. This means that not all scanner findings are real vulnerabilities. So always verify critical findings manually before panicking. The last thing I will mention on interpretation of scanner results is that context matters enormously. A critical vulnerability of an isolated test system that is not connected to anything is less urgent than a high severity vulnerability on your production database server that holds customer data. So always consider the real world context, not just the CVSS score. Good vulnerability management is about smart prioritization, not just patching everything. Vulnerability scanners are not perfect, and understanding their limitation is critical. So let's consider the false positives and false negatives when it comes to vulnerability scanning. Let's start with false positives. False positives happen when they report a vulnerability that doesn't actually exist. Common causes include version detection errors, where the scanner thinks you are running vulnerable version, but you are not, or custom configurations that mitigate the vulnerability in ways the scanner doesn't understand, and compensating controls already in place like web application firewalls. And what's the impact of this? It brings about wasted time because you waste time investigating non-issues. Another impact of this is that it can bring about security team alert fatigue where they stop trusting scanner results. The solution is manual verification of findings, scanner tuning to reduce noise, and documenting exceptions so you don't investigate the same false positive repeatedly. Now let's move to false negatives. False negatives are more dangerous. This is when scanner fails to detect actual vulnerabilities. Common causes include scanner limitations, where the scanner simply doesn't have checks for every possible vulnerability. Another one is zero-day vulnerabilities that no one knows about yet. Lastly, custom applications that scanners can't understand. The impact of this is that a false sense of security and undetected critical risks may eventually become a big problem that will cause a huge harm. The solution to this is using multiple scanning tools to catch different things. You can also do manual penetration testing to find what scanners miss. Lastly, you can do code reviews for custom applications. And what are the best practices for this? The first one is that never rely solely on automated scanners. They are tools, not silver bullets. Secondly, combine automated scanning with manual testing for comprehensive coverage, which means always verify high severity findings before patching production systems. Thirdly, keep scanners updated with the latest vulnerability checks. And lastly, use authenticated scans whenever possible for better accuracy and document known false positives to reduce noise and wasted effort. Scanners are powerful tools, but human expertise and judgment remain absolutely essential. A skilled security analyst with a scanner beats an automated scanner alone every single time. Let's consider the key takeaways in this lesson. The first one is that vulnerability scanning is the automated identification of weaknesses before attackers find them. Scanning identifies issues, and penetration testing exploits them to prove real business impact. OpenVAS is free and it has 50k plus tests. Also, it has unlimited scanning. But Nessus has 150,000 plus tests, daily updates, and it's enterprise grade. Authenticated scans go deeper and produce far fewer false positives than unauthenticated scans. CVSS scale from 0 to 10, which means from critical being 9 to 10, to high being 7 to 8.9, to medium being 4 to 6.9, and to low being 0.1 to 3.9. And we also have the informational aspect, which is just 0.0. Another thing we've learned in this lesson is that we should always prioritize by severity, exploitability, business impact, and exposure level. Then we verify all manually. Also, we saw that false positives waste time and false negatives create dangerous blind spots. So we should always manually verify our findings. Lastly, scanners are powerful tools, but human expertise and judgment remain absolutely essential. That's all for this lesson, but before we go, here is a challenge question for you. And the challenge question is, what is the difference between authenticated and unauthenticated scans? I repeat, what is the difference between authenticated and unauthenticated scans? If you're yet to subscribe to our YouTube channel, please do that now. Also, do not forget to like, share, and comment. Thank you so much, and see you in the next lesson.